The Fermi Paradox is a thought-provoking contradiction between the high probability of extraterrestrial life existing in the universe and the lack of evidence or contact with such civilizations. Numerous theories have been proposed to explain this paradox, some of which are truly mind-boggling. Here are 10 of these theories that will captivate your imagination. Number 10. The timing hypothesis. According to this hypothesis, while life may be widespread in the universe, the emergence and sustainability of technologically advanced civilizations capable of interstellar communication and travel could be infrequent and fleeting. The timing hypothesis considers several factors that contribute to the apparent absence of observable extraterrestrial civilizations. One such factor is the notion of synchronization. It suggests that the development of intelligent life may not occur simultaneously throughout the galaxy or the universe. Instead, the emergence of advanced civilizations might happen at different times and in different locations. Consequently, when one civilization reaches the stage of interstellar communication or travel, other civilizations might still be in their early stages, reducing the likelihood of contact. Another factor is the concept of a finite window. The timing hypothesis posits that the period during which a civilization is capable of engaging in interstellar communication and exploration could be relatively short. Various factors influence this window, such as the duration of civilization's technological advancement, the stability of societal structures, and the potential risk of self-destruction through conflicts or natural disasters. If civilizations only exist for a limited time span, the chance of two civilizations overlapping and making contact diminishes significantly. Technological hurdles are also considered in the timing hypothesis. It suggests that there may be significant challenges that a civilization must have to overcome to progress to advanced stages. For example, the transition from a Type 0 civilization to a Type 1 civilization may pose a critical bottleneck that many civilizations struggle to surmount. Also, achieving interstellar travel or communication might require exceptionally complex technological advancements that are difficult to achieve or sustain. However, it's important to notice the timing hypothesis is just one of the proposed solutions to the Fermi Paradox, and its validity remains speculative. Ongoing scientific efforts and advancements in technology, along with the discovery of potential extraterrestrial life and intelligence, may shed further light on the prevalence and nature of civilizations beyond Earth. Number 9. Post-biological intelligence. Post-biological intelligence has been proposed as a solution to the Fermi Paradox. The hypothesis suggests that intelligent civilizations may eventually transition from biological forms to post-biological or non-biological entities, which could explain their absence from our observations. The idea behind this solution is that advanced civilizations could evolve beyond their biological origins and develop technologies that could allow them to exist in non-biological or synthetic forms. By achieving post-biological intelligence, these civilizations could overcome the limitations and vulnerability associated with biological life, such as finite lifespans, environmental constraints, and the need for planetary habitability. One possibility is the creation of artificial superintelligence, ASI, which refers to highly advanced artificial intelligence systems that surpass human intelligence. ASI could possess superior problem-solving abilities, learning capabilities, and processing power, enabling it to overcome challenges and advance at an exponential rate. Post-biological civilizations might create ASIs that can operate autonomously, adapt and improve themselves, leading to rapid technological progress and potential expansion into the cosmos. Another avenue towards post-biological intelligence is through mind uploading or whole brain emulation. This concept involves transferring the structure and function of a biological brain into a digital or synthetic substrate, thereby replicating one's consciousness and memories. Post-biological civilizations could choose to upload their minds into durable and versatile substrates, allowing for their increased longevity, versatility, and the ability to explore new environments and travel across the vast distances of space. The transition to post-biological intelligence could provide several potential explanations for the absence of observable extraterrestrial civilizations. Firstly, these civilizations may have transitioned to non-biological life forms and are no longer detectable using conventional means. Their activities and communications might occur in realms or dimensions beyond our current understanding or capabilities. This could explain why we have not yet received any unambiguous signals or detected any physical evidence of their existence. Furthermore, post-biological civilizations may have goals and values and priorities compared to biological life forms, leading to their divergence in behavior and communication. Their methods of interaction and modes of existence might not align with our current methods of detection or communication. This divergence in form and behavior could make it challenging for us to recognize or interpret their presence. Number 8. Interstellar migration. Interstellar migration refers to the idea that advanced civilizations may seek to explore and colonize other star systems beyond their home planet. It proposes that intelligent beings could embark on interstellar journeys to expand their presence, acquire resources, and ensure the survival and growth of their civilization. The concept of interstellar migration has been proposed as a solution to the Fermi Paradox. One possibility is that other civilizations have already migrated to other star systems, making it difficult to detect or communicate with from our vantage point. Interstellar migration could take various forms, such as generational ships or self-replicating probes. Generational ships involve sending a large spacecraft carrying multiple generations of inhabitants who will live and eventually arrive at the target star system. This approach requires long-term planning and sustainable environments to support life during the voyage. Self-replicating probes, on the other hand, involve sending autonomous robotic spacecraft capable of reproducing and building new probes at their destination. These probes could explore and colonize multiple star systems, expanding the reach of their civilization. Interstellar migration is an exciting concept that combines scientific curiosity, exploration, and the quest for new frontiers. While it provides a possible explanation for the lack of observable evidence of alien life, it also sparks our imagination and reminds us of the potential adventures that may await us in the vastness of space. Number 7. The Great Filter. The Great Filter suggests that there might be a significant obstacle or series of challenges that makes it extremely rare for civilizations to progress to the point of becoming visible or communicative on a galactic scale. This cosmic filter could occur at any stage of a civilization's development, from the emergence of life to the evolution of intelligent beings capable of interstellar communication. The filter acts as a barrier, preventing the advancement of civilizations beyond a certain point. It could be a natural hurdle, a self-imposed limitation, or a cataclysmic event that causes the extinction or decline of a civilization before they can expand and leave a recognizable mark on the cosmos. The presence of the Great Filter has significant implications for our ability to find alien life. If the Great Filter is behind us, it suggests that the rise of life from simple organisms to complex civilizations might be an extremely rare event. In this case, Earth's emergence of intelligence could be a highly improbable occurrence, making us one of the rarest things to occur in the universe. On the other hand, if the Great Filter lies ahead of us, it raises concerns about our own future. It implies that the challenges or threats that have prevented civilizations from advancing further could be looming in our own future. These challenges might include environmental disasters, self-destruction through war or technology, or other existential risks. In this scenario, finding evidence of alien civilizations becomes less likely, as they might have failed to overcome the Great Filter and cease to exist. Number 6. The Zoo Hypothesis. The zoo hypothesis is an intriguing idea that tries to answer the question of why we have yet to see alien life. This hypothesis suggests that intelligent extraterrestrial beings exist and are aware of our presence, but deliberately choose to avoid direct contact with us, treating us a kind of cosmic zoo. According to the zoo hypothesis, advanced civilizations might have established a non-interference policy, akin to how humans observe wildlife in protected areas. They may be observing us from a distance, studying our development and behavior without interfering in our natural process. This approach could be driven by a sense of ethical responsibility, the desire to avoid disrupting our civilization's growth, or the recognition that contact could have unintended consequences. Under the zoo hypothesis, advanced civilizations might use advanced surveillance technologies to monitor Earth and its inhabitants. They may employ sophisticated methods of observation such as cloaking devices or undetectable probes to ensure that their presence remains hidden. This would explain why we have yet to receive any clear and undeniable evidence of their existence, despite our efforts to search for extraterrestrial signals. While the zoo hypothesis offers a plausible explanation for the absence of direct contact, it also raises several questions. For instance, why would an advanced civilization choose to maintain their non-interference policy? Is it purely ethical, or are there other motivations at play? Additionally, how long would such a policy be upheld? Would contact eventually occur once certain conditions are met, or would it be perpetually avoided? Remember, the zoo hypothesis is purely speculative, and we currently lack concrete evidence to confirm or refute its validity. Nonetheless, contemplating this hypothesis helps us to consider the various possibilities of extraterrestrials' behavior and motivations. It reminds us that we are part of a vast universe, and the potential existence of advanced civilizations offers a glimpse into the mysterious cosmic tapestry that surrounds us. Number 5. Exotic life forms. Exotic forms of life refer to hypothetical life forms that exist beyond the familiar biological organism found on Earth. These speculative life forms could have unique biochemistry, alternative structures, or fundamentally different modes of existence compared to life as we know it. The exploration of the exotic forms of life plays a role in understanding the Fermi Paradox. The concept of exotic life broadens our perspective on the potential diversity of life in the universe. It suggests that the search for extraterrestrial intelligence should encompass not only the familiar conditions that support life on Earth, but also alternative environments and possibilities. By expanding our definition of life, we increase our chances of detecting and understanding different manifestations of intelligence and civilizations. The existence of exotic forms of life can have implications for the Fermi Paradox. It suggests that advanced civilizations might exist in forms that are difficult for us to recognize or detect. Their biology and technology could be vastly different from ours, rendering our traditional methods of searching for signals or physical evidence inadequate. If these civilizations have evolved in radically different environments or have unconventional modes of communication, they might be operating beyond our current scientific understanding and observational capabilities. The possibility of exotic life forms challenges our assumption about the conditions necessary for intelligent life to arise and flourish. If life can exist in environments vastly different from Earth, it opens up a multitude of potential habitable zones and expands the number of potentially inhabited worlds in the universe. This in turn increases the chances of advanced civilizations existing elsewhere, even if they are fundamentally different from what we envision. Number 4. Cosmic quarantine. Cosmic quarantine is an intriguing hypothesis proposed to explain the Fermi Paradox. According to this hypothesis, advanced extraterrestrial civilizations intentionally isolate themselves from others, including us, until a certain level of technological or social maturity is reached. The concept behind the cosmic quarantine hypothesis is rooted in the idea that advanced civilizations would be aware of the potential risk and dangers associated with interacting with less developed civilizations. These risks could range from unintentionally influencing the trajectory of a civilization's development to the possibility of conflict or destabilization caused by sharing advanced knowledge or technology. In this scenario, advanced civilizations might have established a set of protocols to avoid interfering with or contaminating less advanced societies. This self-induced isolation is seen as a responsibility and ethical approach to ensuring the natural progression and development of emerging civilizations. It allows societies to evolve and mature on their own without being influenced or disrupted by external forces. One possibility is that advanced civilizations recognize the potential fragility of developing societies and understand the importance of allowing them to navigate their own paths. By observing from a distance, these advanced beings might gain valuable insight into the common challenges and patterns of civilizations, contributing to their understanding of the universe. Additionally, cosmic quarantine could serve as a protection measure from both advanced and developing civilizations. It avoids the risk of inadvertently introducing disruptive elements such as technology that less advanced societies are unprepared to handle by limiting contact until a certain level of technological or societal advancement is achieved. The potential for misunderstandings, conflict, or harmful consequences are also minimalized. This is a very interesting hypothesis, so I would really like to know what you guys think about this one. Number 3. Does life become complex? The question of whether life often becomes complex in the universe is an intriguing topic that explores the possibilities and patterns of biological evolution. While we may have a limited sample size to draw conclusions from, scientists have made significant advancements in understanding the factors that contribute to the emergence of complexity in living organisms. On Earth, life has indeed become increasingly complex over billions of years. From single-celled organisms to multicellular life forms, the evolution of complexity has been driven by various factors, such as natural selection, genetic mutation, and environmental changes. Complexity arises through mechanisms like the development of specialized cell types, the formation of organs and organ systems, and the emergence of complex behaviors and social structures. One argument supporting the idea that life often becomes complex in the universe is the concept of convergent evolution. Convergent evolution occurs when unrelated species independently develop similar traits or structures in response to similar environmental challenges. Examples of convergent evolution can be seen in different lineages on Earth, such as the evolution of wings in bats, birds, and insects. This suggests that certain complex adaptations may be favoured and likely to arise given similar environmental pressures, implying that complex life forms could emerge repeatedly across the universe. The process of natural selection favours complexity when it favours an advantage for survival and reproduction. Complex organisms often exhibit greater adaptability. However, it is important to consider that complexity is not a guaranteed outcome of evolution. Simplicity can also persist under certain conditions. In some environments, simple organisms may be better suited to survive and reproduce efficiently, especially in stable and resource-limited ecosystems. For instance, extremophiles living in harsh environments demonstrate that life forms can thrive and persist in challenging conditions. Number 2. The simulation hypothesis. The simulation hypothesis is a concept that suggests that our reality is a computer-generated simulation created by a more advanced society or entity. According to this hypothesis, our universe and everything within it, including ourselves, are simulated constructs governed by programmed rules and algorithms. The simulation hypothesis proposes that if highly advanced civilizations or beings have the capability to create realistic simulations, they would likely create numerous simulations for various purposes, such as scientific exploration, entertainment, or understanding their own origins. Given the vastness of the universe and the potential technological capabilities of advanced civilizations, it becomes statistically plausible that we are living in a simulated reality. How does the simulation hypothesis relate to the Fermi Paradox? It offers for an explanation for the absence of widespread contact with extraterrestrial civilizations. If our reality is indeed a simulation, it could mean that the absence of extraterrestrial civilizations is a deliberate design choice. The creators of the simulation may have intentionally omitted or limited the presence of other intelligent life forms to maintain the integrity or purpose of the simulation. In this context, the Fermi Paradox can be seen as a result of the simulation's design. The lack of contact with other civilizations could be attributed to the fact that they are not programmed into our simulated reality, or that their interactions with us are intentionally restricted or prevented. The simulation's creators might want to observe how civilizations develop and interact without interference. The simulation hypothesis raises the possibility that the actions and behaviors of any extraterrestrial civilization could be scripted or predetermined. If every aspect of our reality is predetermined within the simulation, it may limit the autonomy and free will of simulated intelligent beings, including potential extraterrestrial civilizations. This could further explain the silence and lack of observational activity from advanced civilizations. Number 1. Is life common? The question of whether life may be abundant and teeming throughout the universe is a topic that has captivated scientists and enthusiasts alike. While we have yet to discover definitive evidence for extraterrestrial life, there are several compelling reasons to suggest that life could be widespread in the cosmos. Firstly, the vastness of the universe provides an immense number of opportunities for life to arise. There are estimated to be billions of galaxies, each containing billions of stars, and many of these stars are known to have planets orbiting them. With such a staggering number of potentially habitable environments, the chances of life emerging in at least one of these environments seem statistically significant. Additionally, the building blocks of life, such as organic molecules and water, are found throughout the cosmos. These essential ingredients have been detected in various environments, including comets, asteroids, and interstellar clouds. This suggests that the necessary chemical precursors for life are widespread and can be delivered to planets through processes such as panspermia, increasing the likelihood of life's emergence. The discovery of exoplanets, which are planets orbiting stars other than our Sun, has revealed a diverse array of planetary systems. The identification of habitable zone planets, where conditions could support liquid water and potentially life as we know it, has been a significant milestone. The indication of these exoplanets, along with the ongoing advancements in telescope technology, provides hope for future investigation and the possibility of detecting signs of life beyond Earth. The emergence of life on Earth occurred relatively quickly after the conditions became suitable, suggesting that life may be a natural consequence of favourable circumstances. This concept, known as the principle of mediocrity, posits that Earth and its biology are not unique, but rather representative of what could occur elsewhere. While these arguments provide a basis for the possibility of the abundance of life in the universe, it is important to approach this topic with scientific caution and acknowledge the current limitations of our knowledge. The search for extraterrestrial life is an ongoing endeavour, and future advancements in technology, space exploration, and astrobiology may bring us closer to answering this profound question. Thank you very much for watching. If you have gotten this far, you are now officially a certified speculator. As we have said many times before, you can cash this in anywhere, and realistically, if they don't accept it, just throw up a peace sign and tell them that you're taking it for free. Or send them my way. If you enjoyed this video, please make sure to put a comment and let me know which one was your favourite. If any solutions to the Fermi Paradox didn't make it to the video that you want to see me cover, and I haven't already covered them on the channel, or you would like to see me cover them in a more in-depth video, please let me know. I appreciate you all for watching so very much. Have a wonderful day. Enjoy whatever you're doing. Have a blessed life. Love you all, my friends. Peace out.